What I want to look at here is something called pulses, and quite important. We've got a string, we attach it to a wall. We then go to a flick. A pulse travels along, right? Now the speed of that pulse is dependent on two things. That is the tension in the string, so we'll call that tension, and the density in the string. So the velocity is actually inversely proportional to the square root of the density and proportional to the square root of the tension. So as the density gets bigger, it slows down. As the tension gets bigger, it speeds up. So what's going to happen though? It speeds along there and it hits the wall. Now the wall's this big solid. Yeah. It's going to pull up on the wall, but the wall is going to pull down on the string. And so what's going to happen is the pulse is going to be inverted. And now that means if we flick another pulse along, we've got another pulse, got more than just that one, that one, that one, they keep coming. When they meet, they're going to interfere with each other, and we're going to get to use this principle called superposition, which tells us that if a positive amplitude and a negative amplitude meet, they cancel. And this is called destructive interference. We're going to see an example too, where if a positive and a positive meet, then we get constructive interference. So we've got a few of these to look at. We have the inverted against the block wall. What if we just have going into a more solid medium? Tension's the same, density increases, so the pulse is going to go slower in the denser medium. So we've got the pulse coming along, right? Now, as usual, it's going to hit the dense medium, it's going to pull on the dense, and the dense is going to pull on it, and we'll get a little bit of a pulse reflected. But we'll also get some pulse transmitted, because it's not so solid that, and even with the block wall, you'd have had a little bit of pulse done there. And that's going to continue on its way, but slower. That one still goes the same speed as that one because they're in the same density and same tension. And these two little guys, their energy is going to add to the energy of the incoming pulse. No energy lost. So this is reflection and this is transmission. Now if we don't have anything, we just have a free end and we have our pulse, then the free end behavior is that this will just flick up in the air and then it will flick down and the pulse will come back the other way. So now we've got that pulse going that way and that pulse going that way. So this is free end. This one up here that we already looked at was fast to slow. So that's like the refractive index on this side getting bigger. This is just free end behavior. So these two are going to superimpose on each other, or superposition, and we're going to get increased amplitudes when they cross, twice the amplitude. So that's constructive interference. Now, I think there's one that we haven't looked at, which is what happens when we go from slow to fast. Now in this one, we've got a pulse and it's traveling at a certain speed. When it gets there, it's going to travel even faster, right? But we are still going to get a little pulse come back as if this was, so this one is going to pull down on this one, but not as much. So we will actually end up with a little wave going back this way. So we will get a reflected pulse, but it's going to be in phase, if you like. It's not going to be inverted. And again, as usual, these two guys are going to add up with their energy to this. Remember, this one's going to go faster, these little ones are going to go at the same speed. So we do get, again, a transmitted pulse, a reflected pulse. The reflected pulse, though, when we go from a more solid medium to a less solid medium, is going to be in phase. Alright, so those are the little things you need to know about pulses.